Hello and welcome to your site assessment. My name is Stephen Richardson and I am the field technician that assessed your property. I am from Creative Energy Solutions LLC. We are an affiliate of North Carolina State University here in Raleigh, North Carolina. So here at Creative Energy Solutions, our ultimate goal is the satisfaction of you, the customer. And based on the site assessment performed on your property, we really wanted to look at the resources that you have available and what we can do to best exploit those resources to help alleviate some of the energy costs that you, the customer, experiences due to the grid-tied power consumption. We also want to provide you as many options as possible with both short and long-term return on investments in mind, and basically what's going to be the most economically feasible solution based on the resources that you have available. So just a basic overview of your site's energy consumption throughout the property. So your current daily usage is at 35 kilowatt hours per day, with your monthly usage at about 1,058 kilowatt hours. Your load factor for the property is at a 36%, and that's based on your peak hour usage, which was assessed to be 4 kilowatt hours. The capacity factor is going to vary throughout the day, and we'll cover that a little bit later in the presentation, based mainly on the stream flow and the availability of the flow there. So, as mentioned before, you do have a stream available adjacent to your property there, and our early measurements of flow have indicated that this stream is indeed suitable for a micro hydro system. So in this first figure here that I've created, just to try to simplify some of the intricacies of the micro hydro system, in this left portion of the figure here, we have a top view of the stream flowing through the property and our proposed intake system here, which we will cover a little bit later as well. But the intake system is represented by this gray box here, with this rectangular parallel lines representing the penstock that is eventually going to flow to your turbine in the turbine house. This just a cross-sectional view here to show a little bit of the stream bed, some of the topography, as well as, again, the intake system here, and your penstock traveling to the right side of the figure. So based on your site, the intake system that I would suggest to make the least impact on the stream itself would be either a simple pipe with a screen or a screen box. Ultimately, would probably recommend the screen box, as it's likely to pick up or redirect more of the flow in periods of lower flow, as opposed to the simple pipe with screen, since it does have a lower surface area and has the potential to not gather as much of the water. The average flow for the stream on the property is around 1,250 gallons per minute. The minimum hourly observed flow is 238 gallons per minute. So that low flow, or the minimum flow, really dictates our design flow, which we assessed would best be suited at around 150 gallons per minute, and that is also dictated by the static head at your property, which is 65 feet. So the second figure here that we created is also an exaggeration, namely the incline of this hill here, which is, again, largely exaggerated, but we do have represented here. So your change in elevation from the stream up here at your intake system is going to be 65 feet. Your penstock length is going to be 200 feet. which is going to travel from the stream up here down the penstock and then into the turbine house, where it will then, the water flow will exit the tail race and then be reintroduced back into the stream system. On back at the turbine house, we do have the generator and converters that will eventually go to your transmission lines, which will go to the areas of property that need loads supplied to them. These are above ground lines, likely not the case on your property, but this is just for visual representation. So again, going over some of the things I mentioned in the last figure, the penstock length that we're going to be using is going to be 200 feet long, with a diameter that we're going to be suggesting at 4 inches. This is going to be the best suited diameter pipe for this application. The penstock material, however, that's going to be a decision left up to you. We are either going to suggest a PVC plastic or a HDPE or high density polyethylene penstock material. So we calculated also a high and low dynamic head, the high being 61.8 feet and 52 feet for the low. Based on all these parameters, we suggest a turbine configuration of 975 watt hours. We want to see an impulse system with either a Pelton or Turgo setup. The nozzle selection of the system, we would recommend a 3/4 inch nozzle with potential to mix the sizes, and that's going to base on the times of variable flow from the stream, so we can better utilize the pressure and flow of the penstock. Again, with the transmission lines, you have very localized transition to your loads, so we are really expecting very low losses for the transmission on your property. So we have a couple of factors that we need to consider for the construction of this microhydro system. Probably the most influential, however, is going to be the penstock material. We would suggest either a PVC material, which is a cheaper material overall, but due to its susceptibility to abrasion and impact, as well as sharp bends, we would recommend burying this penstock, but burying it will incur an additional cost and may drive up the overall cost substantially. In lieu of the PVC, and probably what we would suggest if you intend on keeping the property long term, is the HDPE. It is a more costly material, but for long-term durability, it is honestly second to none. From some of our early calculations, and based on the turbine setup that we recommend, you're going to create an average of 700 watt hours of energy each hour over the day, and based on that, your grid-tied energy consumption is going to drop by 48%. So it doesn't totally alleviate your dependence on grid-tied power, but 48% is a pretty good drop. But you will still need to be tied to the grid provided. So the cost of the turbine system is going to be provided to you at a later date, and those figures are going to come directly from the manufacturers. So currently there are no federal or state incentives for this project, but my team and I will continue to monitor for any upcoming legislation that may be to your benefit. So this concludes our presentation for your site assessment, and we really just want to thank you for choosing Creative Energy Solutions. And if you have any questions or concerns, please contact me at the email or phone number that I've provided you before.